Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. We are starting our series on finding areas and perimeters of different shapes, but in this particular video, we're looking at finding area and perimeter of trapezium and rhombus. If this is the first time the channel, you're welcome. We're waiting for you and we're glad to have you here. Make sure you subscribe to our channel, like our videos when you go on to watch them, and if you have any question, any comments, want to say well done or something like that, drop it in the comment section. I'll reply to all comments as soon as I can. Without further ado, let's get started. So we're talking about area. We said it's the space the shape covers, measured in square units, and we said for two-dimensional shapes the area is calculated. For three-dimensional shapes, talk about the total surface area. These are not new things if you've been following our videos, and we use this picture to always represent what an area is. Now down to trapezium. So what is a trapezium? A trapezium, or a trapezoid, is a four-sided quadrilateral. A quadrilateral is four-sided with one pair of parallel sides called the base. So let's see an image. So this will be the parallel sides, this place here and this place here. So these two places are called the bases, and the other two non-parallel sides called legs. So these are the two non-parallel sides, this place and this place, right? This place here and this place here, these are the legs. And then the perpendicular distance between them is the height. So you can see the height here is perpendicular distance from here to here is the height. So we said it consists of one pair of parallel sides called the bases, these two sides, and the other two non-parallel sides are called the legs. So what types of trapezium that we have? We have the scalene, we have the isosceles trapezium, we have the right trapezium. I mean, from types of triangle, you should have an idea of what each of these guys should be. But a scalene trapezium is a trapezium with all the sides not equal, right? So a trapezium with all the sides not equal is called a scalene trapezium. And because no side is equal, no two angles are equal. They all have different angles. While for isosceles trapezium, it has an equal length of legs. So this leg, this guy here, and this guy here, these legs, they are equal in length. So a trapezium that has an equal length of legs is called an isosceles trapezium. That is, in an isosceles trapezium, the two non-parallel sides are equal. So this guy here is equal to this guy. And for a right trapezium, it has a right angle pair adjacent to each other. So this is a right angle and this is a right angle. This is a right angle pair that are adjacent to each other, here and here. So when you have a trapezium that has a right angle pair adjacent to each other, you know that that is a right trapezium. Now, to calculate the area of a trapezium, we use the simple formula half a plus b. A plus b is like the bases, right, times h. If you look at this is almost similar to the area of a, I mean, you can say rectangle, just that for a rectangle we'll say length times breadth, right? So you say the same thing, but because these two guys are like different lengths, so we are finding the average of them. So a plus b divided by 2 give us the average width, and then we'll multiply by the height. So it's just basically the same thing, just in a different way. Here we're taking the average of the two sides and multiplying it by the height. So we said where a and b are the length of the parallel sides and h is the height. Let's see an example. Example 1 says that in the diagram below, PQ is equal to 10 centimeters. So where's PQ? These are PQ. PS is 8 centimeters. Where's our PS? This is our PS. And the angle PSR. So this angle PSR. So this angle here is 60 degrees. While SRQ is a right angle. So this is a type of what trapezium? Great, right angle trapezium. A right trapezium. Then find SR, find the length of SR. We're given PQ, we're given PS, we're told that this guy is 60 degrees, and we should find the length of SR. I want to pause the video and try this out yourself. Just try something. Welcome back. Let's look at it together. So if I look at this, if I draw a line, let me just draw a faint line. Great. So you agree with me that if I draw this perpendicular line here, from here to here will be the same distance from here to here, right? Because this is right angle, this is right angle. Here to here is same distance. So this place here is 10 centimeters. Don't say we should find SR, which is this length. So we know one part of the length. So it's this other part that we don't know. But we know that the length of SR would be equal to x plus 10. We know that. So how can we find x? We have if you see this place, we have a right angle triangle. This is like a right angle triangle too. We have the adjacent and we have the hypotenuse. So we have the adjacent and we have the hypotenuse. So if you're doing SOHCAHTOA, which you just fall into car, right? So we could say cos 60 degrees would be equal to adjacent, which is x, all over hypotenuse, which is 8. So x is equal to 8 cos 60 degrees, right? So that means our length of SR would just be equal to 8 cos 60 degrees plus 10. So 8 cos 60 degrees, that will give you 4, then plus 10, that will give you 14. So this is 4 plus 10, which is equal to 14 centimeters. So our answer here is D. If you got this word onto you, great. Example 2 now says that in the diagram above or below, PQ, where's PQ? PQ here is 4 centimeter. CS is 6 centimeters. We're given this length. If the area of the parallelogram PQTU, this area here is 32 centimeters squared, find the area of the trapezium PQRU. This is from JAMB 2004. I want us to solve this example together. So I told that PQ is 4 centimeter, CS is 6 centimeter. If the area of the parallelogram PQTU, so where is PQTU? This is, so if I take this area out, we know that what is left is something like a triangle. This is what they want us to know, something like a triangle. And if this side here, you can see these 3 lines, that means that these 2 sides are parallel to each other. If this is a parallel to each other, that means whatever line is in between them will also be the same length, like this line here. So as this place is 4 centimeter, this place also will also be 4 centimeter. You might want to take a minute to let that sink in. Great. And we're told that the area of this parallelogram is 32 centimeters square. We know the area of parallelogram is the base times the perpendicular height. So just say B times perpendicular height, right? So that means that if the area is 32 and the base is 4 centimeter times h, if I divide it by 4, my height is going to be 8 centimeters. That means that the height of this guy here is actually 8 centimeters based off of the parallelogram that we have here. You see why all of these are actually linked to each other. Now that the height is 8 centimeters, I can find the area of this triangle, right? This place is 4, that means that this total length is 10 and the height is 8. So we know the area of triangle is half base times height. Our base is 10, so that will be half times 10 times our height is 8. 2 here 1, 2 here 5, and that will give you 40 centimeters. So we have the area of this triangle, right? So the area of the trapezium PQRU, we have the area of this place and the area of this place. So the area of the trapezium will just be the area of the parallelogram plus the area of the triangle. The area of the parallelogram is 32 plus the area of the triangle is 40. So our answer here is 72 centimeters squared. This is a very tricky question and it works on your understanding of a lot of things, right? So but let's see if our answer is correct. Great. If this question was strange to you, please take time to watch it again. Remember, this place here is a triangle. We're just giving the area of just this other part. So just by juxtaposing, you will know what to do. Example 3 states that the area of the trapezium given below is 48 centimeters squared. What is the value of x? Take it from NECO 2001. I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. So the area of the trapezium, what do we say the area of trapezium is? Area of trapezium is half a plus b multiplying h, where a plus b are the bases. So that would be what we're given. We're told that the area is 48 centimeters square, the a is 5 centimeter, the B is 7 centimeter, and this is the height. Whatever this guy is basically saying, this perpendicular height, you can see the right angle. So our H is X. So that would be 48 is equal to half 5 plus 7 multiplying X. So that would be 48 is equal to half times 5 plus 7 is 12. Then this would be just times X, basically. 2 here 1, 2 here 6. So that would be 48 is equal to 6X. And if I divide both sides by 6, my X will be equal to 8 centimeter. Simple and short. If you got this, well done to you. But let's see if our answer is correct. That will be option D. Great. Example 4 says that PQRS is a trapezium. These are P, these are Q, these are R, these are S. Is a trapezium. Is that correct? Yes, because this is parallel to the side. QR is parallel to PS. This is what this means. Right. PQ is 5 centimeters, so this PQ 5 centimeter. QR is 6 centimeter. PS is equal to 10 centimeter. This PS, and the angle QPS or QPS is equal to 42 degrees. In a theory question, they might not actually give you this diagram, but it is contingent on you to actually draw the diagram. The drawing of diagram should that you actually understand what is being taught or what is being asked of you, or you understand the question. So calculate correct to the nearest centimeter square the area of the trapezium. This take from 2009. I want you to pause the video and try this out yourself. Welcome back. Let's get it together. So the area of trapezium is half A plus B multiplying H. We're given A, we're given B, but we're not given H. But we're given this small representation. So if I have a, let's see if I draw a line here, a perpendicular line, this will be like 90 degrees. So for this small triangle, which is right angle triangle, what do we know? This place is parallel to this place. The angle here is 42 degrees. The hypotenuse here is 5. And we're trying to find the area of the parallelogram. But to solve this, we need the height, which we're not given. But now, let's assume that we're given the heights here. And I mean, for the sake of this small triangle, we have the H, we have 5, we have 42. These opposites and these hypotenuse. So this sine, right? So our sine theta, okay, let me just do it here. So our sine theta would just be opposite, which is H, all over hypotenuse 5. So and our theta here is 42 degrees, right? So our H will be equal to 5 times sine 42 degrees. Let's see what that gives us. Our H is 3.346 centimeter. Great. So now that we know this, we can be able to find all the other things. Let me just erase this guy. So this is half 6 plus 10 multiplying 3.346. So this is 16 divided by 2 multiplying 3.346. 2 here 1, 2 here 8. So 8 times 3.346, this will give me 26.78 centimeters square. So but they said to the nearest centimeter, so that will be approximately 27 centimeters squared. So our answer is option A. I hope you actually got the step in which I used to solve this particular question. Once again, if it's a theory question, please ensure that you are writing what is given, you are writing the formulas, you are showing every step they are taking, and you're not making the teacher to assume anything. If you have to write and say, oh, taking the square root of both sides, or divide, I mean, just do whatever you have to do to get your full marks. But let's see if our answer is correct. Great. Now we're in perimeter. What is perimeter? We said perimeter is total distance around the edge of a shape, and perimeter of a trapezium is the total length of its 4 sides. So if we have the 4 sides, side 1, side 2, side 3, side 4, by the time we add all of that, we'll have the perimeter. Example 5 now says that in the trapezium X, Y, M, Z. So these are our X, these are our Y, these are our Z, these are M. This is a trapezium. You can see the right angle. This guy is also be 90 degrees by default. So you can see the parallel. XY is parallel to MZ. Great, you can see that. And the angle XYZ, so this angle here is 90 degrees. When I told that PZ is 6 centimeter, so this is PZ 6 centimeter. MZ, so MZ total length is 9 centimeters. That means this guy is 3 centimeter. And MX is 5 centimeter. What is the perimeter of the trapezium? Let's take from NECO 2002. I want you to pause the video and try this out yourself. Welcome back. Let's get it together. So if you're given this, if this guy is 6 centimeters, this guy is also 6 centimeters. That I know. If this guy is 9 centimeters, this guy is 6 centimeters, this guy is 3 centimeters. So we have this side, we have this side, we have this side. It just means this side, which is like the perpendicular height, right? And it's also the same for this guy here, which is h. And this is a right angle triangle, because this is a perpendicular height. This is a right angle triangle here. There's actually a shortcut. I know we've not thought about it, but if you have a right angle triangle, this guy is 3, this guy is 5, this guy will be 4. But let's see. So using Pythagoras theorem, we could say the hypotenuse squared is equal to the adjacent squared plus the opposite squared. Please, if it's a theory equation, before you solve any equation, please always write down the equation. Hypotenuse is 5 squared, adjacent is 3 squared, opposite is h squared. So 25 is equal to 9 plus h. So 25 minus 9 is equal to h. Our h, so this is meant to be h squared. Our h squared is equal to 16. So if I take, I'm going to say, take square roots of both sides, our h will be equal to 4 centimeters. Right, you know it's plus or minus 4, but there's no either is negative value, so always take the positive value, because minus 4 times minus 4 give you 16, plus 4 times plus 4 give you 16. But when we're dealing with height, we don't have negative heights, so that means that this h here is 4 centimeters. So we could say therefore the perimeter is equal to let me start from here, 6 then plus 4 plus total length, which is 9, then plus this length, which is 5. So 6 plus 4 plus 9 plus 5, that will give you 24 centimeters. So our perimeter is 24 centimeters. I want to pause the video and try to find the area of this trapezium. Welcome back. If you did that correctly, you should have gotten 30 centimeters squared. So that's basically it about trapezium, but let's see if our answer is correct first. Great, 24 centimeters. That's basically about trapeziums. You can comb the past questions of NECO, of WAEC, of JAMB, and all the textbooks, like any facts in mathematics, new general maths. I recommend those textbooks, they're very good, right? And solve many questions that you can. So next I'm moving to the rhombus. So what is a rhombus? A rhombus is basically a quadrilateral with all 4 sides equally length. So it's a quadrilateral, but all the 4 sides are equal in length. You might say, is that not the same thing as a square? We'll see for that one. For rhombus, opposite angles are equal. They didn't say all angles are equal, they said opposite angles are equal. And diagonals are not always equal in length, but they bisect each other at right angles. 2 things to note: the opposite angles are equal, and the diagonals are not always equal in length, but they bisect each other. They bisect each other, that means that where they intersect, they divide each other by unequal halves. And then they bisect each other at 90 degrees or at right angles. So the main difference between the square and the rhombus is that all the internal angles of a square are right angles, whereas they are not right angles for a rhombus. So you need to note that. So this is an example of a rhombus. So this angle here will be the same as this angle here, and this angle here will be the same as this angle here, and these are the sides A, B, C, D, which are all equal in length, and these are the diagonals. This diagonal is not the same thing as this diagonal in terms of length, but from here to here is the same thing as from here to here, and then from here to here is the same thing as from here to here, because where they intersect, they bisect each other at right angles. How do we find the area of a rhombus? First is by using diagonal. So we could find it saying the area of a rhombus is half d1 times d2 when you have diagonals. So if I have diagonals d1 and d2, I would just say half times d1 times d2. If I have the base and the height, basically I'll just say base times height, where the base is one of the sides and the height is the altitude or the perpendicular distance from that chosen base, that one that you're using, to the opposite side, right? As if it's just a normal square or rectangle or something. And the third method is using trigonometry. So I mean, if you have one of the sides b, right, and you have one of the angles, so you could just say area is b squared times sine a. So this method is used to calculate the area of the rhombus when the side and one of its internal angles are given. Let's see the example. It says that the area of a rhombus is 110 centimeters squared if the diagonals are 20 centimeter and 2x plus 1 centimeter long. Find the value of x. From WAEC 2015. Also, to pause the video and try this out yourself. Welcome back. Let's solve it together. So we know that the area here is 1 over 2 times d1 times d2. Our told that the area is 110 centimeter squared. Our d1 is 20 centimeter and our d2 is 2x plus 1 centimeter. So let's substitute. So that will be 110 is equal to half times 20 times open bracket 2x plus 1. So 2 here 1, 2 here 10. So 110 is equal to 10 times 2x. That will give you 20x. 10 times 1 will give you plus 10. So let's create like terms. That will be 110 minus 10 is equal to 20x. Then 100 is equal to 20x. Then if I divide both sides by 20, this will cancel this will cancel this will be 5. So our x is equal to 5.0, and that will be option E. Let's see if we're correct. Great. Example 7 says that which of the following about the rhombus may not be true? And this from WAEC 1991. Opposite angles are equal. Is that true of a rhombus? Yes, it's true. The diagonals bisect the angles through which they pass. I did not mention this, but it is true. So the diagonals bisect the angles through which they pass. So if you see, let's say these are rhombus, right? And this is the diagonal, this one diagonal. So you can see it is bisecting this one, 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 bisecting this one. So you need to note that. So the option B is correct. The diagonals bisect each other, yes or no? Yes, they bisect each other. The adjacent sides are equal, yes or no? Yes, remember we said all the sides are equal, so that's true. This was option E. The diagonals are equal. We stated it before that diagonals are not necessarily equal, except in the case of a square and a rhombus and a square, although they're similar, but they're not the same. So for a rhombus, the diagonals are not equal. So this is a contrary statement to that, so I would cancel this. So our answer should be option E. Great. Question 8 says that a side and a diagonal of a rhombus are 10 cm and 12 cm respectively. Find this area. This thing from WAEC 2012. I want us to solve this together. So imagine these are rhombus, and let's see this one diagonal, then this another diagonal. Great. So it says the side is 10 cm, so this 10 cm because all sides are the same. This will be 10 cm, this will be 10 cm, this will be 10 cm. And a diagonal of a rhombus, so the other guy is diagonal, which is 12. So if we assume that this is one that is 12, so you can see that this point of intersection, we don't know the length of this other guy, we just know the length of one of them, right? Because the diagonals are not equal. So if this is the one that we know, if this is 12, that means that at this point this place will be 6 cm and this place will be 6 cm, right? Because they bisect each other. Now if you see, and it said they bisect each other at right angle, so there's a right angle here, so I can bring out that small triangle, right, and say this is right angle. This place is 10, this place is 6, right? So we don't know what this height is, so this, let's say, is x. So using Pythagoras, and what does it state? That the hypotenuse squared is equal to the opposite squared plus the adjacent squared, right? So that is 10 squared is equal to x squared plus 6 squared. So that's 100, let me say, minus 36 is equal to x squared, and that will give you 64 is equal to x squared. So if I take square roots of both sides, our x will be equal to 8 centimeter, right? So this place here is 8 centimeter, this place is 8 centimeter, and because you know this side, whatever the length of this half is, will be the length of this other half, so this place it will be 8 centimeter, right? 8866. So that means that the first diagonal, our D1, is 12 centimeter, and our D2 is 8 plus 8, which is 16 centimeter. So the area will just be half times 12 times 16. So 2 here 1, 2 here 6. So 16 times 6, that will give you 96 centimeter squared, and that will be option D. Let's see if we're correct. Great. Example 9 says that we should calculate the area of a rhombus if the length of its sides is 2 centimeter and one of its angles A is 30 degrees. So I want you to pause the video and try this out yourself. Welcome back. Let's get it together. So we're trying to find the area where one of the lengths, let's call it B, is 2 centimeter and the angle, let me just call it A, is 30 degrees. So we know that we have a formula that the A is equal to B square sine theta, right? And that will be 2 squared times sine 30 degrees. Sine 30 degrees is 1 over 2. So that will be 4 times 1 over 2. So 2 cancel one of the 2's and 4. So that will be 2 centimeter squared. Simple and short. The most important thing is that you must know your formula. Let's see if we're correct. Great. Example 10 also that we should calculate the area of a rhombus if its base is 10 centimeter and height is 7 centimeter. I want you to try this out by yourself. I'm not going to solve this, right? The answer is 70 centimeters squared. If you don't know why, you can rewind back to one of the methods of solving the area of a rhombus and you see the answer in daylight. That is also perimeter. Perimeter is really the total distance around the edge of a shape, as we all know, and the perimeter of a rhombus is the total length of its 4 sides. So that will be side 1 plus side 2 plus side 3 plus side 4. But because all the sides are equal in length, so you just say 4 times the length of any of its sides, right? So any of its side, right, just multiply that by 4. Let's an example. Example 11 states that the diagonals of a rhombus are 16 centimeter and 30 centimeter long. What is the perimeter of the rhombus? I want you to pause the video and try this out yourself. Welcome back. This is from NECO 2004. So let's solve it together. So I mean the diagonals are 16 and 30. So if I have this place, then this place here will be 8 centimeter. This place here will be 8 centimeter. This place will be 15 centimeter. This is a 15 centimeter because there's a bisection that is happening, right? If this is AD is 15 and this is a right angle, if I want to find the perimeter, I need to find the length of its sides, right? So I know that from Pythagoras, I need to find this x from Pythagoras. The hypotenuse squared is equal to the opposite squared plus adjacent squared, and that will be x squared is equal to 8 squared plus 15 squared, and that will be 64 plus 225, and that will give me 289, right? So x squared is 289. So if I take the square roots of both sides, our x will just be equal to 17 centimeters. So that means that the length of one of the sides is just 17 centimeters. Sometimes you see some questions that will say, oh, the diagonals of rhombus are this and this, what is the length of one of the sides? You already know how to solve that. So to now find the perimeter, we just say 4 times any of the lengths, right? And that will be 4 times 17. So 7 times 4 is 8, 2, so that will be 68 centimeters. So our answer for this is 68 centimeters. That is option A. Let's see if we're correct. Great. And that brings us to the end of the area and perimeter of a rhombus and trapezium. I hope you gained value. If you found the video useful, please like our videos. If you know somebody that this channel can help, please spread the word so that a lot of people can come in and learn, and I can grow and you can also grow. I'll see you guys in the next video. Bye for now.